Let's now talk about how the IPv4 datagrams are constructed. You remember, data packet consists of a header with all the organizational data, the administrational data, and the load. This is what the people want to transmit over the internet. This is how the header looks like. We will go through all this fields in the next slide. Important to see is here that here is the source address and here is the destination address. This is, you remember, 32 bits long. And so there are fields with red for some options and some padding, and the data, this later comes, this is the upload. And here, before we have different flags, we have information for fragmentation, we have checksums for error correction, and others. If you have this in mind, let's look to the different things. Here for the data, there is in the IP protocol a maximal data packet length from, not the packet, maximal data length from 65,535 bytes, plus the header gives the packet size. So the version here is 4, is 0100. It shows the version of the IP protocol. Then there is a length of the IP header. You remember there is an optional part, so it's important for the router to know where the header is finishing and where the data are starting. So the length field allows to give numbers, minimal 5, maximal 15 to 30-bit words. Then we had the field with a service type. This was, there are different possibilities to be described here. A priority, different priorities between 0 and 7. D, a delay, the throughput, the reliability. The packet length could be described. It's 16 bits to describe the packet length. The field is 16-bit long. Then we have an identification number, which is used to describe the individual fragments. And this identification number that may be assigned by routers which perform the fragmentation task. Then we have flags. This is the first bit reserved for don't or more fragment. So it is an information in the context of the fragmentation approach. Then we have fragment offsets. This fragment offset is the offset of the fragment in the original data packet. It shows that it is an offset in the original data packet. Then we have the time to live. The idea here is to prevent that packets arrive over a very long time in the internet if something goes wrong with the router transformation. So the time to live gives a number, and this number is decreased by each hop. So after time to live, the number starts, every time is decreased by 1. After the number of live hops, package is ignored. So it's no more forwarded. And then we have the protocol field. In the protocol field, there is a number, and the number gives a higher transport protocol of the next level. We have the field for the checksum. Of course, the checksum need to be recalculated with each hop. Reason is that with each hop, the time to live, a number is decreased, so the checksum is changed. And then we have these options and padding. We will later see there are some routing information that can be given in this option fields, and padding is every time used to bring this in this right length scheme. What are the options which are possible to describe inside a header of an IPv4 datagram? We have the option strict source routing, and strict source routing describes the exact routing path from sender to receiver, and this is done by giving one IP address after another of the intermediate routers that have to be used for the transport of this packet. We have another option also concerning the routing problem. This is the loose source routing. Here only a few routers are specified on the path from the sender to the receiver that need to be visited. Also here the routers are described by their IP addresses. Then we have the option record route, and here that is for testing purposes and others. Each visited router appends its own address here in this option field, so that the receiver can exactly see what was a route the packet has taken from the sender to the receiver. Then there is an option to describe timestamps. Here, not only the address of the router is to put in, but also exactly the time when the router transmits the packet to the next router. Also here, this is important for control purposes that beside of the address, also the time a router was passed is described.